Hello everyone, welcome to Urban Subnet. Today we're going to talk about the TCP IP model. The TCP IP model has two main sections, the Transmission Control Protocol and the IP Protocol. The Transmission Control Protocol, otherwise known as TCP, is a connection-oriented transport protocol. TCP uses sequence numbers and acknowledgments to provide the sending device with delivery information to let it know it's receiving all of the traffic that is being sent. Packets can be resent by TCP if they are lost in transit. This is known as error recovery. The Internet Protocol uses IP addresses to route traffic between networks. The source and destination IP addresses are listed in the IP packet header. This is a header that's on the front of the packet. In addition to inter-network routing, IP provides error reporting and fragmentation for transmission over networks with different NTU sizes. NTU is the maximum transmission unit size. IP represents the heart of the Internet Protocol suite. TCP IP model is a collection of protocols that allow computers to communicate with each other. Every day, millions of people turn on their computers and connect to websites. In doing this, they're actually using the TCP IP model. TCP IP rules are what allows this everyday task to be completed. The computer operating system implements parts of TCP IP model when you log onto the internet and go out and search websites. The model has layers to help break the protocols into smaller categories, which makes it easier to troubleshoot and understand what is the function that is going on within the TCP IP model. The TCP IP network model has 5 layers, and they are the application layer, transport layer, network layer, data link layer, and the physical layer. The application layer is at the top of the TCP IP model. The application layer is a gateway between the network and the application software running on your computer. When software on your computer needs to complete a task like sending an email through the network, the SMTP protocol defines how the email servers send and receive emails. The application layer provides user services like user logins, naming, networks, devices, formatting messages, and email transfers of files. SMTP is a simple mail transport protocol, which is a protocol of the application layer that helps send and receive emails. The most popular application layer protocol is HTTP and HTTPS, which stands for Hypertext Transfer Protocol. It is used by the World Wide Web to manage communication between web browsers and servers. So HTTP is a protocol and language of websites. HTTPS stands for HTTP Secure, which provides a level of security to your websites. It is a combination of the HTTP protocol with Secure Socket Layer, which is an internet security protocol that provides security when you fill out forms like your bank account forms, you want to sign into a secure site, you want to authenticate and carry out bank transactions on your banking website. So the HTTP Secure is widely used. You will notice this if you see a padlock somewhere on your browser. Usually at the top of your browser, you'll see a padlock that shows the padlock is locked, which means that your information is secured and will be transmitted encryptedly across the network. TCP transport layer. The transport layer's main 2 protocols are TCP and UDP. The transport layer services the application layer and provides end-to-end communication. So the layer below the application layer, which is the transport layer, provides services to the layer above. TCP and UDP are the protocols of the transport layer. TCP provides reliable data transfer between end users. Transport layer utilizes flow control to prevent link congestion. So if a server is communicating with your computer and is sending the information too fast for your computer to process, the transport layer will let the server know so it can slow down the sending of the traffic. TCP is a reliable protocol that uses error recovery that sends acknowledgments of receiving data to the sending device. If your device receives a packet or does not receive a packet, it can let the sending device know so the packet can be resent. Missing packets can be resent so that the data can be reassembled in the correct order. So when you're reading an email, you want to see all of the email. You don't want parts of the email missing. TCP connection uses handshakes called the three-way handshake to form a connection between a server and a computer, per se. The process is sync, ACK, and ACK. Now I mention this because this has been asked to me in at least 2 or 3 of my job interviews that I went to. They will ask you, what is a three-way handshake? So remember, the three-way handshake is sync, ACK, and ACK. So just remember that, and we'll touch on that more in other videos. The network layer is Internet Protocol. IP is a major protocol of the network layer. IP addressing and network routing are 2 important functions of IP. Each device on the network requires a unique IP address for reachability. Routers build routing tables to forward packets to their destination based on network addresses configured on the router interface. So each interface or each node will have an IP address. IP version 4 was the first widely used IP addressing protocol. It is 32 bits long, and there are over 4.2 billion unique addresses in this IPv4 address scope. The explosion of the internet caused a shortage of IPv4 addresses. If you believe that 4.2 billion addresses were available, but there was still a shortage after the internet took off. So IPv6 address was developed to add additional address space. IPv6 are 128 bits long, and there are over 340 trillion IP addresses in IPv6. So IPv6 addresses, no one expects them to run out because there's so many of them. And now, since your refrigerator, your car, all of the cell phones out there, everything needs an IP address. So a lot of these devices now will have an IPv6 address instead of IPv4. The data link layer, otherwise known as layer 2, services the layer above it, which is the network layer. Data is delivered across the physical network. The protocols and hardware work hand in hand in the data link layer to send your data across. The data link layer uses link layer protocols to help send IP packets to and from their source and destination devices. This layer is the protocol layer that transfers data between nodes on a network segment across the physical layer. So the physical layer is where your devices connect into the network. The data link frames do not cross the boundaries of a local area network. So that's one important thing to remember. Data link layers do not route. The data link frames, which is the layer 2 frames, are not routed. If you need to communicate with something that is off of your local area network, you will have to use the layer 3 IP routing to send traffic between networks. Data link layer is widely known as layer 2, which is a fallback from the OSI 7 layer model. So the OSI model has 7 layers, which is not used much today. The TCP IP network model is widely used today. The physical layer, which is exactly what it means almost, or what it sounds like, is where we physically plug our devices into the network. Wi-Fi is also on the physical network. We can't feel and hold a Wi-Fi signal, but it is a connection point into the network. So Wi-Fi actually works on the data link and physical layers of the TCP IP model. The physical layers define the cabling and electrical signals that flow through the cables. So these electrical signals are one reason why network technicians need to learn binary math, the base 2 numbering system, because the electrical signals go through at a extremely high rate, and the computer is able to use those signals to process the data and take the binary data that it receives, because computers communicate in ones and zeros, and transform that data into what you're looking at on your screen right now, a power video on a YouTube channel that you can understand, and you won't understand the ones and zeros, but you can understand what you see on your screen. The physical layer provides an electrical, mechanical, and procedural interface to the transmission medium. So that means the transmission medium will be the cable that you connect when you got your modem at home, or you got your cable box at home, and they say, okay, plug this cable into your computer. That is your physical medium, that cable. They got copper cables, they have fiber cables that can be used. They even have coax cables. There's also something that's been tested, sending these bits of information across your electrical cables that use to send electricity through your community. The shapes and the properties of these electrical connectors, the frequencies to broadcast on, the line code to use, and similar low-level parameters are specified by the physical layer. So the physical layer is very important. A lot of times when you're troubleshooting, people will ask you, have you checked or can you check to make sure that the cable is snugly secured into the device, and to see if there might be something wrong with the cable. So the physical layer is an important layer to learn and understand. I also like to end my videos with a little bit of a pop quiz here. So I call it the Pop 3 quiz. So we got 3 questions here we're going to go through. First question is, what is known as a collection of protocols that allow computers to communicate with each other? The answer to that question is a TCP IP model, which we just learned about a little bit about of how this model and the protocols work. Second question is, when devices on the network send frames across the medium simultaneously, frame collisions occur. Which TCP IP layer specifies how devices detect and recover from such collisions? Now this would be called the answer to this is the data link layer. So the data link layer lets, if there's, of course there's multiple devices on the network. If you work in an office, you probably have several people at their desk working. So if there was a case where they would send traffic at the same time across the same medium, the collision detection would go into effect, and one of the devices would wait a certain period of time and then start resending, so to reduce and stop the collisions. Today's Wi-Fi is increasingly popular. This is question number 3. Today, Wi-Fi is increasingly popular. Which layer of the TCP IP model defines Wi-Fi operations? Okay, the answer to that question is the data link and the physical layer, as we discussed earlier. The data link layer helps the transmission of data, and the physical layer is the physical connection point into your network, so that Wi-Fi transmissions are on the data link and the physical layer. So I hope you enjoyed this video. I want to thank you for viewing, and we're going to be following this up with more details on these different TCP IP model layers in the future. Thank you and have a nice day.